Hey everyone, welcome to The Explainer. Today, we're taking what might look like a standard mathematical lesson plan and turning it into a literal, real-world detective toolkit. We're going to focus entirely on finding patterns and formulating rules and sequences. We are drawing directly from a curriculum designed to build some seriously powerful problem-solving skills. Together, we're going to uncover the hidden logic that governs everything from counting your spare change to planning your long-term finances. It's all about closing that gap between simply guessing what comes next and mathematically knowing it for sure.
All right, let's just jump right in. Put on your detective hats for a second and listen to this progression. Peso 100, peso 150, peso 200, peso 250. So what comes next in this line of money and how exactly do you know? Now, most of you probably guessed the next amount instantly without even breaking a sweat. But today, we're going to break down the exact mechanics of why your brain made that logical leap so effortlessly, and more importantly, how you can harness that instinct for much, much more complex challenges. To turn you into a master pattern detective, here is our game plan for today. 1. The world of hidden patterns. 2. Steps to crack any sequence. 3. Solving the savings mystery. 4. Multiplication and subtraction rules. And finally, 5. Applying patterns in life.
Okay, let's kick things off with Section 1, the world of hidden patterns. Let's lay down the groundwork.
You know, a sequence isn't just some random assortment of numbers tossed onto a page. By definition, it is an ordered list that strictly follows a very specific pattern or rule. Think of it like a hidden code just waiting to be cracked. In our source material, understanding this definition is the absolute first step. Every single number has its rightful, designated place, dictated by an underlying, unbreakable logic. You can't just mix them up, or the whole sequence just instantly falls apart. Take a super simple counting example, like 2, 4, 6, 8, 10. Your brain practically does the math before you even think about it, right? You immediately see that each consecutive number increases by exactly 2. Even without formally writing down an algebraic equation, you're already recognizing the sequence and anticipating the next logical step. But the real question is, how do we formalize that innate instinct so we can reliably solve much harder, real-world problems when the answer isn't so obvious?
Moving right along to Section 2, steps to crack any sequence. This is where it gets really good. Our source text gives us a rock-solid 4-step playbook to crack literally any pattern we encounter. To find that missing piece every single time, you must first observe the terms carefully. Second, find the change or relationship between those terms. Third, test that pattern to ensure it holds up across the entire sequence, not just the first couple of numbers. And finally, state the rule in words or symbols. Actually, scratch that. It's not just a playbook, it's a foolproof method for building total problem-solving confidence.
Now, this brilliantly illustrates a crucial distinction we really need to nail down before we get into the algebra. The term is the actual number itself just sitting there statically on the list. The rule, on the other hand, is the hidden engine. It's the underlying instruction manual of how you generate the next number. You absolutely have to discover the rule to unlock the rest of the sequence. Without the rule, you're honestly just looking at a bunch of disconnected data points.
All right, let's put this into practice. Section 3, Solving the Savings Mystery.
Let's look at a totally real-world scenario from the curriculum. Meet Ruby. If Ruby saves 100 pesos in week 1 and then throws in another 50 pesos each week after that, what is her total by week 8? Now sure, you could just count on your fingers week by week, but we are going to apply our 4-step toolkit to solve this contextualized problem mathematically, efficiently, and with 100% certainty.
Step 1, we observe. By organizing our first 4 weeks into a table, we can clearly see the terms side by side. 100, 150, 200, 250. Step 2, we look for the relationship. Looking closely, it's pretty obvious we aren't seeing random growth here. We find that the relationship is a consistent, steady jump of exactly 50 Phillips from one week to the very next.
Step 3 is to test our theory. Visualizing this exact same data on a chart proves our test is absolutely solid. Look how the values climb steadily upwards in a perfectly straight additive sequence. There are no sudden spikes, no unexpected drops. The addition of 50 pesos holds true for every single transition across the data we have, proving that our observed relationship is incredibly stable.
So, that brings us to step 4, the most absolutely crucial part, formulating the rule. We can easily state it in words as add 50 pesos weekly. But to truly unlock the predictive power of the math, we formulate it algebraically as 50n plus 50, where n is the week number. Let me break that down real quick. For week 1, n is 1.
50 times 1 is 50, plus our base 50 gets us our starting 100 pesos. For week 2, n is 2. 50 times 2 is 100, plus 50 gives us 150 pesos. Formulating this algebraic rule acts as our master key for predicting literally any future date.
And here is the ultimate payoff. We want week 8, so n is 8. We apply our newly formulated rule. Multiply 50 by 8 to get 400, then just add our base 50. Boom! That gives us the incredibly satisfying and accurate answer of 450 pesos. By understanding how to formulate the rule, we bypassed all that tedious manual counting and jumped straight to the solution with total mathematical precision.
Let's kick things up a notch. Section 4, Multiplication and Subtraction Rules.
Let's tackle some rapid-fire cases to prove our 4-step toolkit works universally, not just for simple addition. Take a second to observe this new sequence. 3, 6, 12, 24. Look really closely at those gaps. It is definitely not simple addition this time. The jump from 3 to 6 is 3, but the jump from 6 to 12 is 6. So what exactly is the hidden relationship here? By testing the relationship, we realize the rule is an addition. It's a multiplier, times 2. Let's verify it. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. The pattern holds beautifully. It's practically clockwork. So applying that rule to our last known number makes our next term 48. Our 4-step method works flawlessly for multiplicative patterns too.
Okay, what about when things go in reverse? Let's apply the exact same detective logic to a descending sequence, 90, 80, 70, 60. What happens when the numbers are going down? Well, the underlying methodology doesn't change one bit. We just have to adjust the type of mathematical tool we're using for our investigation. The process remains exactly the same.
You probably spotted it instantly. The pattern here is a very consistent subtraction of 10 between consecutive terms. Testing it across the board proves it true every single time. So applying this rule to our final term of 60 brings us cleanly down to 50. Addition, multiplication, subtraction, it literally does not matter. The toolkit handles all of these variations effortlessly.
Which brings us to our final part, Section 5, Applying Patterns in Life.
So why does mastering this mathematical toolkit actually matter when we step outside of the classroom away from abstract numbers? As our source beautifully highlights, identifying these patterns is like having a superpower for everyday life. We're talking about a sorry store owner predicting their upcoming monthly sales, or keeping your household water bill in check, or even just calculating your daily commute budget. All of these daily routines are essentially just sequences waiting to be optimized by you.
And the source material brings up a really fantastic point here. Following these sequences builds massive life skills. Thrift, planning, accuracy. It teaches us that taking small, calculated steps requires genuine patience to reach a much larger goal. Whether you're saving up for a new phone or tracking your daily steps, math is quite literally teaching us how to plan our lives better, term by term.
I love this quote from the text. It really hits the nail on the head. Patterns help us make predictions and solve practical problems. Recognizing these ordered lists isn't just some neat trick to pass a test. It empowers us to solve highly practical problems in our own familiar routines. It's about making your life far more organized, predictable, and putting you entirely in the driver's seat.
So, I'm going to leave you with this final provocative thought to chew on using your new mathematical toolkit. Take a hard look at the routines you repeat every single day. If your daily habits are a sequence, what exactly does your next term look like? Think about it. Thank you so much for joining me for this explainer. Keep observing those patterns, and I'll catch you next time.